We're going to be taking a look at the trig ratios at 30 degrees today. Now, this proof will also apply to the 60-degree triangles or 60-degree trig ratios as well. So keep that in mind as we move through the proof together. So it starts by drawing an equilateral triangle. What do you know about equilateral? We got some question marks here for the angles, and the sides are just notched because they're all equal. So we don't know how big the sides are, and that's important. The sides can be however big they want to be. This has to be the case in order to prove these ratios at these given angles that we're about to solve for. So we can label them all x, because even though we don't know how big they are, we do know that they're all equal because it's an equilateral triangle. Since it is equilateral, that means it's also equiangular. I think it might be equiangular, E-Q-U-I, anyway, it doesn't matter. So we're going to label all of the angles theta. Now, if you know anything about triangles, you know that they add up to 180. So since all three angles add up to 180, we can quickly deduce that each angle is 60 degrees. Now, you might be thinking, well, why 60? Isn't this proof for 30? Yes, it is. But like I said before, we will be proving by 30 and 60 with this proof. So how do you get 30 from 60? Well, you cut it in half, right? So we're pretty much going to go ahead and cut this triangle in half. And by doing that, you can kind of figure out what these two angles are going to be, right? Since this is a perpendicular bisector. Meaning what? Meaning it forms a right angle from the bottom and it cuts the bottom in half. So because that's the case, we can prove something up top here with some little geometry. In other words, those two angles will end up being 30 degrees. Alright? Now, the bottom side was x, if you see from here. Now, if you cut this side in half, each of these will be half of that. So therefore, it will be 1/2 x on both sides. And again, up here it's going to be 30 degrees. So guess what? We have two right triangles now. It doesn't matter which one we use for this following proof. Either one will work because they're the same triangle oriented in different ways. We'll pick the right one. So the right one, we have a new right triangle formed from this equilateral triangle. This is a 60-degree angle. We just deduced that this top angle is 30. So hence we're going to be proving 30 and 60-degree trig ratios. And hypotenuse is x from our original marking, original label. The height we will call b. You can call it h, doesn't matter. The point is we want to get this in terms of x, okay? And that's, you'll see why in the proof. Basically the x's will end up canceling each other. It's kind of like terms. So to do that, we can use the Pythagorean Theorem. Forgive my handwriting here. We will have 1/2 x squared plus b squared equals x squared, the hypotenuse. Again, I'm not going to harbor all of this algebra, okay, because this is just algebra, all right? If you have any questions about any of this, let me know. This is not the gist of what we're trying to do here. We're really trying to get to the trig ratios. But anyways, I will briefly explain. 1/2 x squared is 1/4 x squared. You would subtract 1/4 x squared from both sides. X squared minus 1/4 x squared is 3/4 x squared. Then you want to get b by itself by taking the square root. That will ultimately simplify to the square root of 3 over 2x. And we have now achieved our goal of getting b by itself and in terms of x. So we're going to relabel the triangle with that in mind. Alright. So now we can label that b, height side, square root of 3 over 2x, and now we are ready to prove our trig ratios. Let's start with sine. Again, we're proving at 30 degrees, so we're going to start here. Just remember that when you're solving for a trig ratio or trig of an angle, it all starts at the angle. That's why the angle goes inside the parentheses. That's your starting point. That's your input. Okay, that's the input of your function, as we know in pre-calc. The output depends on the trig ratio. For sine, it's opposite over hypotenuse. So you do opposite side divided by hypotenuse. So it's going to be 1/2 x over x for our first proof. So we're going to just simply plug this stuff in. 1/2 x over x. The x's will cancel. And we've proven no matter how big that 30, 60, 90 triangle is, which came from that equilateral triangle, doesn't matter how big it is, it's going to be 1/2. Now, again, we can write that as a percentage, as I've done before, to kind of add clarity. What this means is that the opposite side will always be 50% or half the size of the hypotenuse in a 30, 60, 90 triangle, regardless of how big x is. So what does that mean? That means this side, the opposite side of the 30, is always going to be half of the hypotenuse. You can kind of see here, it looks like it's about half of the hypotenuse. That's all that means, okay? So that's a pretty convenient fraction, right? Sometimes these things get radicals and stuff, and it's kind of confusing. This one's pretty simple. Moving on to cosine of 30. Cosine of 30, well, the adjacent side of 30 is square root of 3 over 2x, right? And the hypotenuse is still x. So it's still just going to be square root of 3 over 2x divided by x, adjacent over hypotenuse. X's will cancel, and we get square root of 3 over 2. So that means that the adjacent side is square root of 3 over 2. Well, the adjacent side we could label square root of 3, and we could actually call the hypotenuse 2, right? And that would be the ratio between them. But again, let's convert this to a percentage to see exactly what percent the adjacent side is the hypotenuse. Of course, it's going to be smaller, right? How much smaller? Okay, I plugged this into my calculator, and I got around 80.86, which is about 86%. So what that means is, I just like percentages. I think that makes sense for a lot of things. This side, adjacent side of 30, is about, 86% of this side. Okay? It just makes sense that way, right? That's what square root of 3 over 2 is as a percentage. And it kind of gives clarity to what a trig function a trig function is, which again is just the ratio of two side lengths, or how much one side fits to another. All right? Now let's do tangent. The opposite of our 30-degree angle is 1/2. The adjacent is square root of 3 over 2. We're going to have to flip that, and then we're going to have to do what? We're going to have to rationalize the denominator. I'm not going to spend a lot of time on this algebra. If you have any questions about any of this, let me know. We get square root of 3 over 3 for our answer. So, again, what is that as a percentage? Well, let's take a look. So I plugged this into my calculator, Desmos calculator, which is an excellent app, by the way. And I got about 50.58, which is about 58%. So what that means is, and again, I'll just kind of write that here for clarity. This one's a pretty cool one, I think. That means that this side is about 58% of this side. It's a little bigger than half of this side. That's all it means. And that's true for any 30, 60, 90-degree triangle. You can imagine just the possibilities of this, especially in construction, when you have so many right angles. And many times when you're building a house, you deal with 30, 60, 90 triangles, or 45, 45, 90, which we'll learn later. Quickly, we're going to do cosecant. The definition of cosecant is the flipped of sine. So right off the bat, you can see, well, actually, I think I skipped a page there. But anyway, it's hypotenuse over opposite, so it's going to be x over 1/2 x, which is going to turn to 2. We've already done the percentages, but this one really makes sense, though. That means that the hypotenuse is twice as big as the opposite side of the 30-degree angle, which makes perfect sense. This is twice as big as this. This one really simple, and I like it when it comes out evenly because it just conceptually makes sense. Moving on to secant of 30. Secant is the flipped version of cosine. So instead of adjacent over hypotenuse, it's a hypotenuse over adjacent. We're going to have to do some keep change flip here, as well as rationalize the denominator. The final answer is 2 square root of 3 over 3. And again, secant is hypotenuse over adjacent. So we might want to get a percentage for that to figure out, how much bigger is the hypotenuse than the adjacent side. Well, let's just put a 2 there. So about 115%. So if we're starting at 30 degrees, that means that the hypotenuse is around 115%. Whoops. Sometimes I mess up there. The hypotenuse is about 115% of the adjacent side. Okay, seems about right. It's a little bit bigger. Now, let's just do a few more here. Actually, I think we just have one more. This video is getting kind of long here. Cotangent. Cotangent is adjacent over opposite, so it's going to be the flipped version of tangent. So it's going to be square root of 3 over 2x divided by 1/2 x. Keep change flips. It's going to be square root of 3 over 2 times 2 over 1. The 2's will cancel, and the final answer is square root of 3. Okay? So I believe that's around 1.7. Let me double check. And indeed it is. So that means that the adjacent side of 30 is about 170% times the opposite side, or of the opposite side, which makes sense. Okay, so for every 100 units here, this would be about 170 units. So there we have the 6 trig functions at 30 degrees. If you have any other questions about this proof or these ratios, let me know.